So today we're going to look at the first part of section 9.3, which is about rotations. A rotation is another type of transformation that is also an isometry or preserves congruence where the pre-image and the image are congruent. A rotation is where you turn an object around a fixed point a certain number of degrees. So every vertex of the figure of your pre-image goes through a specified angle measure and turns in the exact same direction, the same distance, around a certain point. The point around which you move your object is called the center of rotation, and the angle that you turn your object is called the angle of rotation. So for example, we could rotate an object around the origin, around some fixed point, say 75 degrees. That would be our angle of rotation. Just to give you a little idea, let's say I take the letter R, and I want to rotate this letter R 90 degrees clockwise around this point. A 90-degree clockwise rotation turns kind of towards the right, which would make my letter R look like this. Whenever we do rotations in geometry, they're actually assumed to be counterclockwise. So if the directions don't specify, you can always assume it's a counterclockwise rotation. If we were in class, I would show you the next two examples, questions 1 and 2. In order to do these questions, you need a protractor and a ruler or a straight edge. Unfortunately, those are too complicated to do on a digital platform, so I put a link to someone else's YouTube video. If you're interested, you're more than welcome to check this out, but you will not be required to know how to do rotations that are not on the coordinate plane. There are a couple of questions on your homework worksheet about this. I believe it's numbers 1 through 3. You can skip those as well because, again, it's just too hard to show you digitally, and I don't know that everybody has a protractor at their house. So let's just flip over to the back. You are going to be required to be able to do rotations, any multiple of 90 degrees on the coordinate plane. So these rules up at the top, you should memorize. Notice that there are essentially 3 different rules, but they correspond to 6 different rotations. If I rotate an object 90 degrees counterclockwise, so I'm turning my image 90 degrees in this direction, that's the same as doing a 270 degree clockwise rotation, because of course a full circle is 360 degrees. So if I start from the top, go 90 degrees to the left, but then start up at the top again, go 270 to the right, I'd end up meeting at the exact same spot. A 90 degrees counterclockwise rotation, 270 degree clockwise rotation follows the rule where each of the coordinates of your figure switch and the new x coordinate becomes negative. So the rule for the first one here shows you each point, x, y, changes to negative y, comma, x. So your new x value is negative, and then the new y value is your old x. For a 180 degree rotation, there's a rule for that's exactly the same, of course, for both counterclockwise and clockwise 180 degrees. Whether I move clockwise or counterclockwise 180, I'm moving to the exact same place. Doesn't matter which direction I'm going. And a counterclockwise 180 degree rotation keeps your coordinates in the same position, except that it changes their signs. So each point, x, y, becomes negative x, negative y. And the last rule that you have to memorize is for a 270 degree counterclockwise or 90 degree clockwise rotation. So 270 counterclockwise would look something like this. A 90-degree clockwise rotation would look about like this. And for those two, the rule says you take your coordinates, and again, they switch position, but this time your new y coordinate becomes negative. So xy changes to y, negative x. Let's go through two examples together. So if you take a look at question number 3, we have triangle PQR on the coordinate plane, and the directions say draw the image of triangle PQR under a rotation 90 degrees counterclockwise about the origin. So for a 90-degree counterclockwise rotation, we use the rule where each point, x comma y, becomes negative y comma x. Switch the coordinates, make the new x coordinate negative. So if point P was at negative 1, 6, under this 90-degree counterclockwise rotation, P prime should go to negative 6, negative 1. Point Q was at 4, negative 2, so Q prime is going to go to positive 2, positive 4, and because R was at the coordinates negative 7, negative 4, R prime is going to go to positive 4, negative 7. For each of these questions, you should write out the coordinates and then plot your image on the coordinate plane. So now if we graph triangle P prime, Q prime, R prime, it should look like this. Hopefully you're using a ruler at home on your piece of paper so your triangle will look a little bit better, but you get the idea. And again, triangle PQR and triangle P prime, Q prime, R prime are congruent because a rotation is another type of isometry. And in question number 4, I'm rotating another triangle. This time it's triangle DEF. And we're doing a rotation of 270 degrees counterclockwise again. So a 270 degree counterclockwise rotation takes your coordinates x, y, switches them, but this time the new y value becomes negative. So xy becomes y, negative x. Following this rule, because point D was at negative 2, negative 1, D prime is going to go to negative 1, but positive 2. E was at negative 1, 1, so E prime goes to 1, positive 1. And since F was at 1, negative 1, F prime goes to negative 1, comma, negative 1. Again, graph your image. And it should look like this. One of the things I forgot to mention, but is actually pretty important, is that each of the rotations that we just did were rotated about the origin. The 3 rules that are listed at the top of your paper are for a 90 degree, 180 degree, 270 degree rotations only if they are around the origin, or the origin is your center of rotation. Tomorrow's lesson is going to be how to perform rotations on the coordinate plane that are not about the origin, but around a different point. I should have mentioned that at the beginning, but at least make a mental note now that the origin is the center of rotation for these rules. And tomorrow we'll talk about what happens if it's not. Please make sure you complete the homework worksheet attached to this. Again, you can skip questions 1 through 3, but I would encourage you to check out the video to at least see how you would perform those rotations. And then we'll look at the rest of this section tomorrow. Have a great day.